Hey class, and welcome to Chapter 13 lecture. Chapter 13, we're going to be talking about intelligence. First thing is defining intelligence. According to Wechsler, who developed tests that are used widely today to measure intelligence, according to him, intelligence is the global capacity of a person to act purposefully, to think rationally, and to deal effectively with his or her environment. Most experts view intelligence as a person's capacity for goal-directed adaptive behavior. And Sternberg, who we'll talk about more, lists three categories: analytical intelligence, practical intelligence, and creative intelligence. So Sternberg was a Yale psychologist, and he surveyed several hundred lay people representing a broad spectrum of society, as well as over 100 psychologists with a special interest in intelligence. Both the non-psychologists and the specialists were asked to list specific kinds of behavior that they thought were indicative of intelligence or the lack of intelligence. And a list of 170 indicators emerged from this study. So, analytical intelligence is defined as the ability to write clearly, do mathematics, and read critically. Practical intelligence is knowing how to do and fix things, skills, and street smarts. And creative intelligence is the ability to formulate and to solve problems. Okay, so obviously a big part of what we're going to be talking about is how intelligence is measured, and how this relates to different theories of intelligence. There's quite a few of them. So the intelligent testing movement began around the turn of the 20th century, and Alfred Binet and Theodore Simon devised a measure for children's intellectual skills in response to overcrowding and differing abilities of children in French schools. So the French government had recently made education compulsory for all children, but had not anticipated two outcomes of this edict. First, the classrooms were filled to overflowing, and second, teachers now had to cope with a much wider range of differences in students' abilities than ever before. It soon became apparent that a sizable number of children needed special classes. So that's why the intelligence testing, the grandfather of intelligence testing, came to be. And so Binet and his collaborators reasoned that virtually all children follow essentially the same course of intellectual development, but that some progress more rapidly than others. Thus, children of subnormal intelligence were presumed to be merely, quote, retarded in their development. Taking this reasoning one step further, Binet theorized that a child of low intelligence should perform on tests of intellect like a normal child of a younger age, and conversely, that a precocious child should perform like an older child of average intelligence. So Binet coined the term mental level to express a child's composite test score. This term, later referred to as mental age, corresponds to the chronological calendar age of children who, on the average, receive a similar test score. So, for instance, a 6-year-old whose composite score is equivalent to that of a 9-year-old has a mental age of 9. So, the intelligence quotient. I'm sure you've all heard of an IQ test. So a few years after Binet's pioneering efforts, the German psychologist L. Wilhelm Stern devised a simple formula to avoid the problem of dealing with fractions that arose when mental age was compared to chronological age. So his formula, mental age, over chronological age times 100 yielded an intelligence quotient or an IQ score, which provided a rough index of how dull or bright a child was compared to his or her peers. So, for example, a child with a mental age of 7 and a chronological age of 5 has an IQ of 140. 7 over 5 times 100 is 140. So thinking about this, do you think that this IQ formula is applicable to adults, and why is it harder to find proportionate age differences? So if we think about trying to use this for adults, the credibility kind of breaks down for it. As you can imagine, consider for an example a 20-year-old who performs on an IQ test as well as an average 36-year-old. Would it be logical to conclude that the younger person has an IQ of 180? The fact that this is not justifiable indicates why psychologists needed to devise an alternative method for computing adult IQs. So they did this by designing adult intelligence tests, in which IQ is determined by comparing a subject's performance to the average performance of others in the same age bracket. Okay, so the Stanford-Binet Intelligence Scale is the IQ test developed by Lewis Terman, who revised Binet's scale and adapted questions to American students. Lewis Terman normed Binet's intelligence test for Caucasian California students to evaluate how effective test items were for measuring age-related changes. This test is widely used for a longer period of time than any other test of intelligence, and is a highly regarded test with impressive predictive ability to show how a child is going to perform in school, depending on how they score on this Stanford-Binet intelligence scale. Okay, so again, back to the adult intelligence scale. The Wechsler Adult Intelligence Scale. This is an intelligence test developed by David Wechsler in the 1930s with subtests grouped by aptitude rather than age level. So the latest Wechsler Intelligence Scale is the WAIS-4, and there are 4 main areas in this test: verbal comprehension, perceptual reasoning, working memory, and cognitive processing speed. This contains both verbal and nonverbal items and allows for subscale scores and overall IQ, and provides ability to pinpoint deficiencies in intelligence. Okay, so here is this table is an example of subtests from the most recent revision of the WAIS. So take a look at that. It's on page 518 in your book. And you can just sort of take a look at that table and get familiar with the subtests that are part of the Wechsler Adult Intelligence Scale 4. This is an example of a matrix reasoning problem. And if you look on page 519, you'll find this table. The question here is, which set of shapes from the 5 alterations best replaces the question in the matrix, the question mark? So which one of these would you choose to fit in there? So this is an example of matrix reasoning. Okay, so evaluating intelligence tests. So a test must be well designed, reliable, and a valid instrument for assessing the particular abilities that indicate intelligence. Intelligence tests are developed by 4 steps. First, developing test items, then evaluating the test items, then standardizing the test, and then establishing norms. So in order to develop test items, test constructors start with a large pool of potential test items and may create their own or modify from existing tests. For example, the developers of the original Stanford-Binet scale started out with many items that seemed able to differentiate between the intellects of children of different ages. Okay, then evaluating the test items is the next step. Separate effective test items from those, separate effective test items from those that are ineffective or misleading, and administer to large number of subjects who are representative of the intended test population. For example, since the developers of the Stanford-Binet were trying to differentiate between high, average, and low intelligence among a broad spectrum of children, they administered their pool of items to thousands of preschool children. They found that some items were effective in reliably differentiating between children of different age levels and others were not. Okay, and then standardizing the test. This is ensuring consistent administration across all samples and populations to obtain accurate data. As you can imagine, if everyone is administering the test differently, it will be really difficult to figure out if the test is reliable and valid. So standardization procedures are uniform and consistent procedures for administering and scoring tests, such as IQ or personality tests. Okay, and then establishing norms, bell-shaped curve. So a norm reflects the normal or average performance of a particular group of people. For example, if you developed an intelligence test for adults and found that the average score of 20 to 25-year-olds was 185 points, a score of 185 would become your basic norm or standard of performance for people in this age category. Similarly, if 40 to 45-year-olds scored 169 on the average, 169 would be the norm for this age group. So that makes sense. That's just the norm or average that people are scoring a particular group. So a standard deviation then is a statistical measure that indicates the degree to which scores are dispersed around an average. So here you go. Figure 13.2, it's on page 521 of your textbook. It shows you an example of a typical normal distribution of IQ scores. And here along the bottom you see the standard deviations, okay? So here you have the average, and then both higher and lower, above and below that average. Okay, so let's talk a little bit more about test reliability and validity. So reliability. In psychological testing, reliability is the dependable consistency of a test over time, or the consistency in responses among similar items on the same assessment. So since a person's intelligence does not fluctuate widely over time, developers of IQ tests hope to achieve a quantitative consistency in the scores people obtain on their tests. Okay? So to evaluate test reliability, one of these procedures, one method for evaluating test reliability is test-retest. So this is just giving subjects the same test more than once and seeing, if the scores vary widely or what happens there. And then there's alternate forms reliability. This is a method of assessing test reliability in which subjects take two different forms of a test that are very similar in content and level of difficulty. Split half reliability. This is the measure of test reliability in which a subject's performance on a single administration of a test is assessed by comparing performance on half of the test items with performance on the other half of the test items. Okay, so just comparing the halves there of the test. And then validity. This is really important in psychological testing. This is the ability of a test to measure accurately what it is supposed to measure. So you can imagine if you don't have a test that's valid, you're not measuring the correct thing, and therefore the test isn't doing its job. So, assessing test validity. There's criterion-related validity. This is a method of assessing test validity that involves comparing people's test scores with their scores on other measures already known to be good indicators of the skill or trait being assessed. Okay? Concurrent validity is a type of criterion-related validity that involves comparing test performance to other criteria that are currently available. And then predictive validity, type of criterion-related validity assessed by determining the accuracy with which tests predict performance in some future situation. Okay, aptitude tests. These are tests designed to predict an individual's ability to learn new information or skills. These are IQ tests and college entrance exams, like the SAT and the ACT. And then achievement tests. These are tests designed to measure an individual's learning, as opposed to the ability to learn new information. So, like the midterm you just took, this is an achievement test because you've already learned the material and now you're being tested on it. Versus an aptitude test, this is testing your future ability to perform. Okay, let's talk a little bit now about theories of intelligence. So first we're going to talk about Spearman. So Spearman's view of intelligence reflected his use of factor analysis, which is a statistical procedure that enables researchers to identify groupings of test items that seem to tap a common ability or factor. So for example, people who are quickly able to assemble colored blocks to match pictures of complex designs also tend to perform well when asked to assemble pieces of a puzzle. We could view these two behaviors, as well as other behaviors, that reflect an ability to visualize and manipulate patterns and forms in space, as defining a spatial ability factor. So Spearman developed his model of intelligence by applying a statistical procedure called factor analysis to the scores of a large number of subjects on diverse tests that assessed many different intellectual skills and ability. Okay? So Spearman also noted that some subjects consistently scored high on all of the various tests, regardless of what they were supposed to be measuring, and that a roughly equal number could be counted on to score low. People who scored high or low on one kind of test also tended to score at a similar level on other tests, but their scores on various skill tests did tend to differ somewhat. So these statistical observations prompted Spearman to propose that intelligence is made up of two components, a G factor, which is general intelligence, and a collection of specific intellectual abilities that he labeled S factors. According to his view, we all have a certain level of general intelligence, G factor, probably genetically determined, that underlies all of our intelligent behavior. We also have specific abilities, S factors, that are more useful on some tasks than on others. Okay, so think about here, oops, I always do that. Think about Charles Spearman. Think about G and S factors, okay? Okay, now we're going to talk about Thurstone. So Thurston was one of Spearman's strongest critics, and he used factor analysis on the scores of a large number of subjects on over 50 different ability tests, but he found no evidence for general intelligence ability as Spearman has proposed. Instead, he declared that human intelligence is a composite of 7 primary mental abilities, and these are verbal comprehension, numerical ability, spatial relations, perceptual speed, word fluency, memory, and inductive reasoning. So Thurston, think of the 7, okay? That's him. And here you go. Here's table 13.2. This is on page 525 in your book. And this is just explaining in a little more detail what each of these 7 areas mean. So verbal comprehension, the ability to understand the meaning of words, concepts, and ideas. Numerical ability, the ability to use numbers quickly to compute answers to problems. Spatial relations, the ability to visualize and manipulate patterns and forms in space. Perceptual speed, the ability to grasp perceptual details quickly and accurately, and to determine similarities and differences between stimuli. Word fluency, the ability to use words quickly and fluently in performing such tasks as rhyming, solving anagrams, and doing crossword puzzles. Memory, the ability to recall information such as lists of words, mathematical formulations, definitions, etc. And inductive reasoning, the ability to derive general rules and principles from presented information. Okay, now we're going to talk about Sternberg. So Sternberg's initial approach to developing a theory of what he called practical intelligence focused on how people process information in order to solve problems and deal effectively with their environments. Sternberg conducted a number of experiments to study the steps people go through in solving the kinds of problems typically encountered in intelligence tests. He has identified 6 steps, okay? So first is encoding, which is identifying the key terms or concepts in the problem and retrieving any relevant information from long-term memory. Second step is inferring, determining the nature of relationships that exist between these terms or concepts. Third is mapping, clarifying the relationship between previous situations and the present one. Fourth is application, deciding if the information about known relationships can be applied to the present problem. Fifth step is justification, deciding if the answer can be justified. And sixth is response, providing the answer that seems best based on proper information processing at each of the previous stages. So one of Sternberg's most interesting findings is that good problem solvers who score high on intelligence tests spend more time analyzing a question, particularly in the encoding stage, than those who score lower. So that's good for you all to keep in mind as you're working through test questions. High on intelligence tests spend more time analyzing a question, okay? Okay. So in recent years, Sternberg has expanded his information processing approach into what he calls triarchtic theory of successful intelligence. So, according to this theory, intelligence is a multidimensional trait comprising analytical, creative, and practical abilities. So analytical intelligence involves mastering a sequence of components or steps in the process of solving complex verbal, mathematical, or spatial reasoning problems. Creative intelligence is the ability to combine experiences in insightful ways that lead to novel or creative solutions to complex problems. And practical intelligence is exemplified in people who seem to be street smart and have skills to accomplish a variety of tasks. So also very important, Sternberg emphasizes that it is important to consider intelligence within a cultural context. Failing to do so may bias our definitions of intelligence to fit a particular worldview. The range of successful skills and knowledge vary widely between cultures, and these differences must be taken into account in any theory of intelligence. Okay, Gardner. So Harvard University's Howard Gardner outlined a view of human intelligence that reflects both his dissatisfaction with the idea that intelligence is a single trait that can be measured with an IQ test, and his belief that the factorial approach to describing the structure of human intellect fails to capture the complexity, diversity, and practicality of human intelligence. So in this sense, Gardner is philosophically aligned with Sternberg. However, he differs from Sternberg in an important respect because he advocates the inclusion of certain kinds of mental abilities that fall well outside the realm of what has traditionally been labeled as intelligence. Okay? So he includes not only this linguistic intelligence, logical, mathematical intelligence, and spatial intelligence, but also musical intelligence, bodily kinesthetic intelligence, interpersonal intelligence, intrapersonal intelligence, and existential intelligence. So let's talk a little bit more about some of those outliers. So musical intelligence makes sense, right? These would be people who are have intelligence that's manifested by musicians, composers, or other people who express themselves musically. Bodily kinesthetic intelligence, this is overlooked in traditional definitions and involves using one's body or parts of the body to make something or solve a problem. So these could be accomplished dancers, athletes, and craft persons. Interpersonal intelligence is the capacity to perceive and understand the needs, motives, and behaviors of others. So these could be noteworthy and accomplished therapists and teachers. And people who can accurately assess and understand their own needs and abilities and who use this knowledge to function effectively manifest intrapersonal intelligence. And then naturalistic intelligence is the ability to carefully observe the natural world, and existential intelligence is the ability to address questions about one's own existence. Okay, so as you can imagine, a question comes up when discussing intelligence about if it is really linked directly more to hereditary or environment. So researchers have found that parents with high IQs tend to have children with high IQs, and parents with low IQs are prone to have children with low IQs. According to the hereditarian view, genetics determines the structural and functional efficiency of the brain, which in turn clearly influences intellectual functioning. On the flip side, the environmentalist view says that the environment plays a greater role than genes in shaping human intellect. So the positive relationship in parent-child IQs reflects the fact that adults tend to create home environments similar to those they experienced in their own childhood. So we're going to go back to that table after we talk a little bit about what it is. So twin studies, as you can imagine, could be very useful in helping to identify whether that's environment or whether it's genetic. So the intellectual differences that exist among all of us are a product of only two factors, genes and environment. Identical twins reared together are highly similar in tested intelligence. The second highest degree of correlation is in identical twins reared separately. Identical twins reared separately are still more similar in IQ than fraternal twins of the same sex who are reared together. And this finding seems to undermine the environmentalist view that fraternal twins reared together should have a higher degree of IQ correlation than identical twins reared apart. So let's go back to this table here. Table 13.3, which is on page 530 of your textbook. And you can see here the correlation. So identical twins reared together, obviously the highest correlation, reared apart, second highest. Okay, fraternal twins reared together, less than identical twins who are reared apart. And then as we go down, it follows. So identical twins definitely have the highest correlation here, which would definitely correlate with the hereditarian view of intelligence. Okay, really important as we're talking about intelligence to discuss some racial differences in intelligence. So, while many psychologists agree that differences within groups can be partially attributed to hereditary factors, this does not lead to the conclusion that differences between groups, for example, whites and African Americans, are attributable to hereditary factors. So, in order to think about this, there's a useful analogy that's been proposed. So imagine drawing two random samples of seeds from a bag containing several genetically different varieties. One sample is planted in enriched soil, the other sample in regular soil. The plants within each planter will differ somewhat. This within-group difference is attributable to genetic differences within each random sample of seeds. The plants grown in the different soils, which would be environmental conditions, will also differ. Most likely, the plants grown in the enriched soil will be much taller than the ones grown in regular soil. This difference is a between group difference, and it is attributed to both random genetic differences and the different environment conditions. It would be a mistake to claim the differences in height between the two groups of plants was attributable to the genetic differences in the samples alone. Okay, so hereditability is an estimate ranging from 0 to 1.0 that indicates the proportion of variance in a trait that is accounted for by hereditary. Okay, here's a diagram of what we're talking about with the seeds in the soil. So in the normal soil or poor soil, you'll see that within this group, there's some variance between plants, right? Because it was a random handful of seeds. So not all the plants are going to be the same due to their genetic makeup, okay? Same thing in the good soil. Not all of these plants are going to be exactly the same because of their genetic differences. However, also really important to take into account the fact that there is some environmental difference going on here too. So you can't just say that these plants are different just because of hereditary differences. They're also all different because some are grown in this good soil and some are grown in this poor soil. Okay? So that's a diagram of within group, which is, like I was saying, the hereditary differences that exist within the same group, and then between group differences. So that's taking into account the differences between these two groups. Okay, so talking about how this relates to differences between African Americans and whites. Arthur Jensen, who is an educational psychologist and a hereditarian, is probably the most controversial advocate of the viewpoint that IQ differences are due primarily to hereditary. For over 25 years, Jensen and his colleagues have been arguing that hereditary accounts for approximately 80% of the differences in IQ scores between African Americans and whites. This is an extreme position that has not always been supported by research. Okay? Numerous studies conducted over the last 50 to 60 years have found that African Americans score an average of about 15 IQ points, which is one standard deviation below American whites on standard tests of intelligence. So, for instance, on the Stanford-Binet test, the difference between African Americans and whites was 17.4 IQ points for the age group 12 to 23 years. However, as figure 13.4 reveals, the scores of significant numbers of both African American and white individuals fall at all points in the distribution, and there is a great deal of overlap between the two races on IQ scores, which you can see in this diagram. Furthermore, the fact that the range of scores for both groups extends from very low to very high indicates that the IQ differences among individuals within one racial group are profoundly greater than differences between the average scores of two groups. And finally, a substantial number of African Americans have IQs that far exceed the average IQ for whites. So, given this information, even Arthur Jensen conceded that all levels of human intellect are present between both races, but we are still left with the puzzling matter of a 15-point spread between. So today, the opinion among many psychologists is that intelligence differences between racial groups are largely the result of environmental factors. The findings on which this conclusion is based come from a variety of research studies. In fact, researchers have argued recently that the difference between African American and white scores has decreased by about a third since 1972, and that the present difference is about 10 points. So in conclusion, the safest thing to say is that neither genetics nor environmental conditions alone account for the difference in intelligence observed either within or between groups of individuals. Experiments with animals and correlational studies with people seem to suggest that genetic differences can be overridden by environmental circumstances. And unfortunately, the history of intelligence testing has been largely motivated by attempts to justify racial attitudes, which is inappropriate. And also, just interesting and maybe good for you all to think about. What are your thoughts about this difference here in IQ scores? And also, what are the environmental differences that people of different races face? How could that affect IQ tests? How could it affect IQ tests that IQ tests were all developed by, white men? Do you think that that has anything to do with the difference there? So just some things to sort of think about and ponder about, and hopefully that attitude about the difference in IQ scores is shifting and not not used any longer to justify um, inappropriate and outdated uh, racist beliefs. So that's our lecture for to this week about intelligence. I hope you learned something, and I hope you have a really good week.